In 1987, the Instituto Goiano de Radioterapia in Brazil sat partially demolished. Left behind inside the ruins was a piece of radiotherapia equipment that had fallen entirely out of the regulatory system. It was an Orphan source, a dangerous radioactive device completely abandoned by the authorities meant to track it. Looking for scrap metal, two scavengers entered the clinic, hauled away the heavy lead and steel assembly, and took it home to begin dismantling it. After days of prying at the casing, they managed to puncture the 1 millimeter thick iridium window protecting the source capsule inside. Shortly after, both men began to vomit. They attributed the sickness to food poisoning, unaware they were experiencing the early symptoms of acute radiation syndrome. Because the chain of custody was broken, a lethal, invisible threat was released into the public, disguised as ordinary scrap metal. The scavengers eventually sold the punctured assembly to a scrapyard owner named Dever Alves Ferreira. Once the capsule reached the scrapyard, Dever noticed a strange phenomenon. The material inside emitted a mesmerizing, ethereal blue light. This is known as Cherenkov radiation, caused by charged particles traveling through a medium faster than the speed of light. Dever believed he had found a magical powder. He brought the breached capsule into his home, inviting family and friends over several days to see the glowing substance. Radiation provides no sensory warnings. It has no smell and emits no heat. This lack of physical feedback allowed natural curiosity to turn a deadly isotope into a neighborhood attraction. The specific isotope involved was cesium-137. It was in the form of cesium chloride, a radioactive salt. This salt is uniquely dangerous. Unlike a solid metal source, cesium chloride is highly soluble in water and easily crumbles into a fine dust. These salt particles bind easily to environmental moisture, skin oils, and clothing fibers. At the scrapyard, friends and family innocently rubbed the glowing dust on their skin like glitter. The material soon left the yard. Dever's brother took a handful of the dust home and spread it on his floor. His 6-year-old daughter, Laïd, ate a sandwich while her hands were still covered in the radioactive powder. As the neighborhood fell ill, local doctors misdiagnosed the severe symptoms as a localized outbreak of a tropical disease. The dust-like chemistry of the salt meant that every handshake or gust of wind moved the isotope further. Every person who touched the powder became a carrier, physically transporting the radioactive material from the scrapyard into homes and public spaces. Gabriela Maria Ferreira, Dever's wife, noticed that dozens of people in her circle were falling seriously ill at the same time. She identified the blue powder as the single common factor linking every victim. In a heroic act, she placed the source parts in a bag and took them on a crowded public bus to reach a health clinic. A physicist, Walter Mendez Ferreira, was called to the clinic the next morning. He arrived with a borrowed scintillation counter to check the bag. The moment he turned the meter on, it redlined, immediately saturating the sensor. The radiation levels were so high they exceeded the machine's detection limits. Gabriela's intuition finally exposed the threat, revealing that the city was in the middle of a massive radiological emergency. This scale shows the magnitude of the response. Over 112,000 citizens were screened, leading to the identification of 249 people with significant internal and external contamination. Doctors used a treatment called Prussian blue to manage the internal exposure. The compound binds to cesium in the gut, preventing the body from reabsorbing the isotope and speeding up its excretion. Despite medical efforts, 4 people died within weeks from acute radiation syndrome. This included young Laïd and Gabriela Ferreira. The fatalities were a direct result of the intimate exposure caused by the salt's physical form, which allowed it to be easily ingested and absorbed into the body. The environmental cleanup required the total demolition of 7 houses and the removal of topsoil across multiple properties. We can see the difference chemistry makes by looking at the Mayapuri incident in India. That event involved solid cobalt-60 metal, which caused localized burns. Because Goiânia involved a soluble salt, the contamination became systemic and widespread. The cleanup produced 3,500 cubic meters of radioactive waste. It is now sealed in a repository in Abadia de Goiás, designed to contain the material for at least 300 years. The Goiânia accident remains a 300-year monument to the consequences of neglecting the regulatory chain of custody over nuclear materials.